Let's see if we can solve this challenging limit. So we have limit x approaches 0 sin x over x to the power of 1 to the power of 1 minus cosine of x. We know sin x over x is 1 and 1 minus cosine x is 0. So this is in the form of 1 to the power of 0, 1 to the power of 1 by 0, or 1 to the infinity, which is an indeterminate form. So we're going to have two different strategies, maybe perhaps L'Hopital's rule, or we can use the Maclaurin series expansion. So I'm going to use the Maclaurin series, which is a special Taylor series expansion which is centered around the around 0. It's formed by summing up terms involving functions derivatives evaluated at 0 and allows it to approximate a function using a polynomial, especially around the origin. Okay, so let's take ln on both sides. When we do that, we have taking natural log. We have ln of the left, ln of our expression. We did this because we want the exponent to come before the ln and into the denominator. Now, remember, for small values of x, sin x can be written x minus x cubed by, say, and the higher order polynomials. Cos x can be written, cosine x can be 1 minus x squared by 2, and so on and so forth, higher order. Now, when we divide the sin x with an x, sin x by x, we get the series and divide that by x. You get 1 minus x squared by 6 and so on. And 1 minus cosine of x is 1 minus all of this, so it becomes 1 gets cancelled and you have x squared by 2 and the higher order ones. Now, for very small values of y, ln of 1 plus y approximates y, because the very higher degree ones become progressively smaller and smaller. So here ln 1 plus y is going to be, the y value is going to be negative x squared by 6. The reason is this, because we said ln sin x over x, we say sin x over x was 1 plus minus x squared by 6, and the higher order ones, which we are not going to take into account because they're very tiny. Okay, so this is negative x squared by 6, the ln sin x over x, because we're just going to take this, approximate the y value. And for our expression, our limit, we're going to take the sin x over x and substitute with the negative x squared by 6. And we already said 1 minus cosine of x was negative x squared by 2 in the higher order, but they're getting smaller and smaller, so very tiny. So we can just take this one. Now we flip it, we get negative 1/3. So log L to the base is negative 1/3. We use the log and exponent principles. So e to the power of negative 1/3 is the value of our limit. So let's graph it and see if that is actually true. By sin x over x to the power of 1 minus cosine of x, as we approach 0 from both sides, you see the y value is approximately 0.71, which is e to the power of negative 1/3. So yes, our work is done. Have a nice day. I'll talk to you in the next video. Bye.